All right, here's our video on motion, our first video on physics. As you can see, we're going to be talking about velocity, speed, distance, and displacement. So first we should know what's the difference between velocity and speed. We hear that a lot. But we also should know what is motion. Well, we know what motion is, right? So we'll write motion, and we're going to talk about different types of motions in other videos. But motion is it's a change from point A to point B. Right? You went from point A to point B. All right. If this was, here's point A, wherever you are. Let's say you were in Brooklyn. You're at point A and you're heading to point B, wherever point B is. Maybe point B is out in the Hamptons, right? You're at East Hampton. So that's a change in your position from A to B. And when you're in middle school and high school, you see, before you get into physics, the distance is rate times time. And you can also have as the rate could be the distance over time, or the time could be distance over rate. And we're going to look at those equations. So let's say you were going, and let's say we used red. So let's say you're going 60 miles per hour. Well, that's your speed. It's your rate. You're going 60 miles per hour. But if I say you're going 60 miles per hour east, well, that's your velocity. So remember, velocity has direction. Velocity has direction. It has direction and magnitude. So here's another word that popped up. Magnitude is size, right? How big or how small something is. It also could be in miles, right? So the magnitude is 60 miles. That's magnitude. But remember, velocity doesn't just have magnitude, it has direction. So you're going 60 miles per hour east is velocity. You'll also hear the words vector and scalar. We'll talk about in other videos. So velocity is a vector because vectors have magnitude and direction, where speed is a scalar. It only has magnitude. Keep that in mind. So if we look at a very simple problem here, let's say you were going 50 miles per hour for 3 hours. So we have our time, we have our rate, and 50 miles per hour, is it speed or velocity? It's velocity, right? We don't know which direction we're going. We just know we're going 50 miles per hour for 3 hours. And so we know our distance will be 150 miles. Now, sometimes when you get these questions, we're not sure if you were going 50 miles per hour at a constant rate. Let me explain that. So clear this out. Here we are at point A, wherever you are in point A, and you're heading to point B. And of course, it doesn't have to be a straight line. It could be however direction it was. And you went 200 miles. You went 200 miles, and by the time you went from point A to point B, it was 5 hours. Now, what we don't know is we don't know your rate. And if when we get the rate, we're not sure if you were doing that rate consistently. So we know our distance is 200 miles. We know our time is 5 hours. We just don't know our rate. We do a little algebra, and we can find our rate. So you were going 40 miles per hour. But were you doing 40 miles per hour consistently? We're not sure. You could have went from point A and then maybe you stopped. Maybe you stopped over here for gas, or maybe you rested, maybe you ate. So you could have been going 60 miles per hour, then you stopped. Maybe you went 80 miles per hour and you stopped again. So we don't know exactly our rate. We do know that it came out to 40 miles per hour, and we'll call that the average speed. There's also average velocity. So it's usually written with a V and average. So the average velocity will be distance divided by time. In this case, the average velocity will be 40 miles per hour. Because we know 40 times 5 is 200, right? Now velocity, the average velocity is different because we need to know the difference now between distance and displacement. So let me do that next. So let's clear this out. Let's talk about a number line here. So let's make a number line. See a lot of questions on physics with number lines. And we'll start at 0. 0 is your home. Let's say this is where, well, let's say Joe's over here, a guy named Joe. And Joe's here. This is Joe's home. It's at 0. And let's say he's going to the deli 5 miles away. So each unit here will be a mile. There's 5 miles. There's the deli. And let's say Joe went 5 miles. And you'll see he'll go 5 miles to the right. He went 5 miles to the right. He got his meatball hero or whatever he got. And then he's going to go, then he goes, let's say 12 miles to the left. He's going 12 miles to the left. So from here at the deli, he has to go this way. And 12 miles plus the 5, so it means he'll be over here, 1, 2, 3, 4, 5, 6, 7. He'll be at -7 over here. So if we look at his distance, let's say over here was his girlfriend. See, his girlfriend's Gloria. It's at Gloria's house. Hopefully he bought lunch for her also. So his distance, the total amount that he traveled is his distance. So over here, he went 5 miles to the right, then 12 miles to the left. So what do you think his total distance is? 17 miles. He went 5 miles here. He went 5 miles back, plus another 7 miles to Gloria's house. So his total distance is 17 miles. His displacement is how far away he is from his house. His displacement is only 7 miles. He's 7 miles away from his home. That's the difference between displacement and distance. Let's look at another picture. Rewind if you have to. So here's point A, whatever that is, and let's say point B is over here. And there's a lake. Say there's a lake between them. And so the road goes like this, kind of hugs the lake, and it reaches there. So let's say from A to B, if you take the road, it's 50 miles. Let's just say it's 50 miles. The distance you traveled is 50 miles. Your distance that you traveled is 50 miles. But if you want to know how far A and B are from each other, that's their displacement. So we can use this dotted line. And let's say the dotted line displacement is 40 miles. So the displacement is only 40 miles. See the difference? Sometimes you hear that idiom or the adage, as the crow flies, right? A bird can fly across the lake, or you can take a boat maybe, if there was a boat available. Otherwise, you would have to travel around the road. So your distance is the total amount that you traveled, whereas your displacement is actually how far you are from where you started. So if Joe and Gloria are going to a concert, right? It took them 50 miles. They're 50 miles away, but they're only 40 miles away from their home as the crow flies. That's displacement. So let's look at two questions. Let's see if we can do this. Let's clear this out. Let's say we'll use Joe and Gloria again. Joe and Gloria. I wonder how they're doing, right? Joe and Gloria are on a trip, right? And let's say they go 480 miles. They went 480 miles in 10 hours. So we can look at their average velocity. We'll say their average velocity, we'll put the v with the average there. The average velocity is distance over time. That's their average velocity. So we know that their average velocity, AVG, sometimes you see a v, will be 480 divided by 10. That'll give us their average velocity. Their average velocity was 48 miles per hour, but we don't know while they were driving if they stopped. Did they stop somewhere? We don't know, but we know their average velocity is that. Average speed. That's their average speed. Very important. Average speed. Average speed is that, not velocity. So and we really couldn't do average velocity here because we don't know, again, 480 miles. We know they're going 48 miles per hour, but we don't know if they're going north. We don't know if they went north and south. We don't know. We don't have any of that parameters to help us with average velocity. But let's look at an average velocity question. Average velocity. So if we're going, let's say you're going 100 miles, you're going 100 miles west. Now we have velocity here. It's 100 miles west. And you're doing that in 6 hours. Then, we see that then pop up. You turn around for some reason. Who knows why you're turning around? You forgot your keys. You turn around and then you're going to go 50 miles east in 4 hours. So if we look at it in the number line here, so this is where we started at 0. Remember, we started at 0. And we're going to say west is to the left. That's what it is on the map. So here we are at negative 100. And then you turned around and you went 50 miles this way. You went 50 miles that way. So now we know that you're 50 miles from home. That 50 miles from home is your displacement. The total distance you traveled, though, is 150 miles. That's your total distance. So we want to find average velocity. I'll clear this out and we'll do it over. Get some more room. We'll clear this out. So again, you went 100 miles west in 6 hours. And then you went 50 miles east in 4 hours. So here we're going to put V, and you're going to put a line on top of the V. This is because we know it's average velocity. And average velocity will be this delta symbol, Greek delta, which means change of x over the change of time. It's just a fancy for saying velocity is going to be your distance over time. It's just a fancy way of saying that. But it's a change of x over the change in time. And the change of x in this case would have been 50 because you went, your distance, remember, your distance was 150 miles. That's how much you traveled. But your displacement, how far you are from your home, is only 50 miles. Make sure you remember that distance there. So your 50 miles is your change of x, and you went 10 miles. So 5 miles per hour is your average velocity. But there's something missing. What do you think it is? When you're doing the average velocity, so we'll put the average velocity up here. And all you have to do is just put that arrow, that line, not arrow. So what you're doing is we're doing negative 100. That's where he went to. Went to the left first. Plus 50. And then we divide it by 10. So we're saying negative 50 over 10, which gives us negative 5 miles per hour. Now, it's not negative 5 miles per hour. What it's saying is our direction is to the average was to the west at 5 miles per hour. And so what you would normally see is the velocity with an arrow pointing this way saying 5 miles per hour. All right, and in our next video, we're going to talk about instantaneous speed and more about motion.